Okay. We'll get started in a couple minutes here. Just wait to make sure we've got everybody. Cbor, yes.
After 68 slides, so.
All right, let's go ahead and get started then.
Yeah.
Okay, if we could come to order, please. If we could, we're gonna talk about Cbor now, which is why everybody's here and excited. So that this is the first meeting of the Cbor working group, and your chairs today, Joe Hildebrand, and this is Francesca Palambini. All right, and so we're just going to go through a little bit of current state and talk about some of the business that we've got on our table, and then we'll have some time for discussion at the end. So let's go ahead to the next slide. This is the note well. Hopefully by this point in the week, you will have seen this several times. The most important thing is that you have responsibilities with respect to your intellectual property rights for anything that you say here or anything that you contribute to the conversation. So please make sure that you have read these and discuss them with your lawyer if you need to. Next slide. I can't see the slide now. All right, okay. Yep, so we're recording everything too here, which is nice for us to be able to recover what happened. All right, so here is what, I'm gonna stand up so I can see this. Is this one working also? Check, 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 test, okay. Quiet. All right, I'll just speak up. All right, so obviously we're gonna do a little bit of intro stuff here. We'll talk about the status of the current Cbor RFC and the things that we would like to do in this version of that. Karsten will talk about those. We'll talk about the Cuddle draft and decide if that's the way that we want to move forward with the charter item that we've got to be able to specify Cbor in drafts that use Cbor, etc. And then there are a few items here of new tag types for different kinds of semantics that people might want to use in Cbor, and we'll discuss those and decide where we're going with them. If at the end there's time left over and people are interested, we can do some more tutorial stuff on Cbor. If there's anybody in the room, I don't know if there's anybody in the room that needs that in order to participate in the discussion. I don't think. If there is, raise your hand. All right, so at the end we can have some general discussion, clarifying what it does and how it does it, or what have you. So we'll see if we have time left. Any agenda bashes? Go back to any issues people have? Yes. Between the two of you, it will have been discussed. All right. Let's go ahead then. All right, so we've got a GitHub org. Here's the URL for it. There's going to be one repository for each draft that is accepted as a working group work item. and the editors will have commit privileges. We'll talk over time about precisely what our policies are with respect to pull requests and how complicated they can be without review and that sort of thing. But let's start relatively lightweight and see how far that gets us. If you've got anything that's just a typo, feel free to just sort of send a pull request on that. If it's anything more interesting or substantive or affects the semantics in any way, please make sure that we've discussed that on the list. Questions? All right, let's move forward. All right. We have not decided that yet. I'm hoping that we come to some consensus on that as we work. All right, so given that, let's go to Karsten, and you can talk about current state. That's full screen.
See where this thing goes. So, this is one of those microphones that you have to hold very closely. So, I want to talk quickly about where we are with Cbor. Some of these slides have been used in the Cbor Lightning tutorial that I held at IETF 94. You can dig them out somewhere in the maze of links that the edu team leaves behind, or you can find them on my home directory somewhere. So go through the slides for this meeting and click on this link, and then you can find the full slides. So just a quick background, maybe stealing a couple of minutes from the tutorial part at the end. This whole thing has a really long history, and actually I will
actually, if you don't mind, let's just assume that folks in here have most of the history and skip ahead, and then
Yes. So a slide later actually will cite RFC 40. So there is a long history, and let's just skip that part. So we finally arrived at the idea of taking the JSON data model and putting in things. So the Cbor data model is an extension of the JSON data model with a number of items that turned out to be important. And the two most important items were byte strings and tags. Byte strings, so we can send binary data as binary, and tags, so we have an extension point. JSON doesn't have an extension point, Cbor does. And there are a few other smaller things where Cbor has a little bit more flexibility than JSON. So I'm going to keep this very short. Yeah, so the point was filling in this hole and avoiding some not so great binary protocols that are out there. And the whole thing is optimized for small code size and compact data size. So the result is called concise binary object representation. When you speak the name, think about a Cbor. Yeah, and that fills the corner in the corner model. So we went to the trouble and actually documented in the RFC what our specific design goals were. Because, of course, when you change your design goals, you get a very different binary representation. And the design goals were kind of a given. We didn't really discuss them in the process. But, of course, we did discuss the result of that. So about 3.5 years ago, we got the RFC in a process that was officially for the IETF AD sponsored. In reality, we had a lot of feedback on the apps area working group mailing list, on the apps discuss mailing list. So it felt a lot like a working group process, but yeah, it wasn't officially one. So that has been a little bit of a sore point for some people who are using this now. There is a site, Cbor.io, where you can find resources that are of interest. This morning I looked at the data tracker and looked which documents are out there that actually reference Cbor. It's way more, it's going down here. So there apparently is some interest now. There are a few implementations. This is an old screenshot. There should be slightly more than 30 implementations out there now. And this is not so surprising because if you're a competent programmer, you implement Cbor in one afternoon. So it's not that hard to do it. Cbor has batteries included, and that's maybe something that's important for this working group. So the RFC defines 18 tags for things like time, big numbers, various converter helpers, URIs, my messages. And we made it easy, very easy, to register new tags. Some people say too easy. We may want to revisit the IANA considerations when we go ahead with this document. But for now, that actually turned out useful. So we have 19 more tags registered, 6 of which are for COSI, which I will come to in a moment. And well, there are other things like UUIDs, binary MIME support. We somehow did the MIME support wrong here and only allowed text-based MIME messages. There is Perl support, so the Perl people jumped on this, and they have a few more data types that we just didn't support. Language tags, strings, of course, are important, and somebody finally decided to put in a specification for that, and various ways of doing compression. Cbor is normally often used for small data where compression is not so important, but if you want to do larger data, then it's nice to have some compression without having to go through a separate compression algorithm like deflate or brute. Okay, one other thing that happened here is the COSI working group. And the fun thing about the COSI working group is that this came and went. I mean, they did their thing. The document is done. It's in the RFC editor queue. It's the only one that has off status right now. I'm not entirely sure what that means. Okay. So why? Okay. So it should be RFC soon. And it's basically using FOSI and trying to use the fact that Cbor has binary encoding, so this is useful here. Yeah, so why do we need a working group for something that seems to be chugging along nicely? Yeah, one idea is to just take it to internet standard. We have this process defined in RFC 6410. And there are 4 tick marks we have to make. Interoperable, independent implementations. Now we have that, we still have to document it. No errata. Yeah, there are 2 errata on very stupid errata on 7049 in the examples in the text.
Very good errata.
The errata are good, and yes. The third thing maybe is the most interesting part. An internet standard is not supposed to have unused features. So when we look at interoperable implementations, we should find out, are there any features that nobody has picked up? And those cannot become internet standard. So if we find something that is unused and we still want to keep, we could factor it out into a separate document, or just say, oh, it's over there in the old document, use it if you want to. For instance, if it's a tag, the tag is already registered, we cannot unregister that. Yeah, if nobody uses it, that's interesting to find out. So we have to do a little bit of searching here, that there's some actual work required. The fourth point is, if there are patent claims, the licensing process has to be used at least twice. I'm not aware of any patents. And so I think that should be very easy to fulfill. But this documenting this and checking our features, that's really the work that needs to be done. So this is not an invitation to futz around with a draft. We're not reinventing the wheel here. We're documenting interoperability. We may want to make needed improvements in specification quality. So clearly fix the errata, but also if there are other things that are not so clear, maybe this is the time to fix them. And I think, again, most of the potential here is in the tag descriptions. So the base document, I think, is pretty clear, but in the tag descriptions, there may be a little bit where we want to improve the description. And yeah, do this interoperability checking, do a metrics. That's really what we have to do. So the next step would be to do a repo for 7049 bis. Right now, the organization only has repos for other drafts. And that probably should lead to a draft IETF, Cbor 7049 bis, or however we want to call it. And then we should start the process, whatever process we come up with. I wouldn't mind being relatively strongly GitHub oriented here, because that makes the job of the editor simpler. But if the working group wants to do this in a different way, I'm happy with anything here. And we also need to start this feature interoperability list that might be done by a wiki. I think we have to find out what other people have done for their feature interoperability lists and maybe learn from that. So yeah, that's my summary of where we are.
So I'd invite comments from anybody who thinks that that list has things on it that it shouldn't, or vice versa, it needs things on it that are not there.
Hi, Carson. Carrie Lynn. I'm wondering, is there anything like a test suite or test vectors or anything that accompany this, so somebody doing a new implementation can be sure that they've done it correctly? Do we need something like that?
We don't need it.
Okay.
We may want to go beyond what we have. So right now there is the examples in the RFC. Those are available as a Cbor file. But of course, the examples are not completely covering everything. So we don't have an example for a mind message or something like that. And maybe this is a good time to actually make this more complete. I think that's a good time.
Could, I don't know if we have a charter for the working group, but it potentially could be an action item.
We could still do it. I mean, individuals could still do it.
Joe Hildebrand from the floor. I've got a pretty comprehensive test suite for Node Cbor. I've gotten pretty close to 100% coverage. I think I'm missing like one line I can't quite get to. Not to say that that's enough, but it at least catches all the error conditions that I know about, in addition to all of the features. And I also have a fuzzing suite that I use against my stuff as well. So we could pull that out into a separate repo and just all start collaborating on that as a separate thing. I don't think that necessarily needs to have an ID or RFC associated with it unless we all decided that it needed to. Yeah, sure. But once we get, so I'm happy to start up a repo for that and to have us, and I'll populate it. Yeah, I'll create a new repo under Cbor WG that has just the test vectors, unless anybody has an issue with that. All right, I'll at least get that started for us. Yeah. Thank you.
Brian Carpenter, and question from ignorance, I think. When a new tag is defined, does that need to go into 7049 bis, or do you have a separate mechanism for formally defining new tags?
We have an IANA registry.
We have an IN registry.
Okay, specification required. Good. Thanks.
There
I'm
are-
sorry. I should have known that, but I didn't.
There are various considerations for various parts of the range. So the really good tags, the 1-byte ones, those require IETF review or something, approximately IETF
Yeah.
review. The next is specification required, so the 2-byte ones are specification required. So there is a designated expert who's standing here, and then the rest is first come first served.
Okay, no, that's fine. And the other thing, I've got the blue sheet if anybody needs it. Otherwise, you can have it back.
So on that topic of what the policy is for the different ranges of tag numbers, if you've got another issue, if we could finish this one off first. All right. So if anybody has opinions about whether that should stay the policy, that's something that I think we could change while going to standard without it being a semantic change or an interoperability change. That's a policy change that we could decide to make. So if anybody wants to set a different approach or thinks the criteria should be different, or if we should provide at least some guidance to the expert reviewer about what we think should go and what shouldn't, that would be an interesting discussion to have.
Well, I do have an opinion on that. Should I do that?
Yeah, go ahead.
Yeah, so as I said, I think it was a good idea to keep this very open for the first 3 years because it was a good way to engage the implementers. We may want to dial back that a little bit because we are starting to consume the 2-byte range. So just having specification required on the 2-byte range may be a little bit too liberal. We may just update the expert review considerations. That's one way to handle this. Or we may upgrade this to a different 5226 class.
So we could also provide some design guidance around, hey, if you're coming up with a new protocol, don't use 50 different tags, use one, and here are some ways to do that, for instance.
Rick Taylor. Yep. Rick Taylor, just following on from that point, I'm not sure if it's a charter item or for a fresh document or to go into the base. I know in the DTN working group, we have recently adopted Cbor, but we've taken our existing protocols that have been handcrafted wire formats and tried to translate them with guys who aren't that experienced with Cbor, so they've started from cold, and a little bit of implementation guidelines, a little bit of guidance of you don't need to roll all your own tags for your own little fields. Actually, it's a slightly different way of thinking about it. We made some mistakes. Carsten was brilliant, got on the list, really helped us sort it out, but we can't just rely on Carsten. It would be nice to distill Carsten into a document.
Could we start with just a little markdown file that we keep in one of these repos, just gather the bits of wisdom that have come around and then take a look at that and decide what kind of document that turns into over time?
Absolutely. And my second point is about the test and fuzz scripts and so on. I have some as well. I'm happy to contribute if it's in a GitHub repo. The more the better. In my
Yeah,
mind.
and we can argue over the format that I use because everybody's going to hate it.
To be honest, mine's awful, so I'll copy yours.
Hi, this is Hank, the note taker. So we want to have this markdown file in another repo just next to all the other ones, so everyone can contribute to it and make that the point also.
Or it could be in the repo with the BIS draft. I don't have a strong opinion.
Okay,
Could be in the wiki. GitHub has
Oh, so it
wikis,
has
Yeah.
a wiki?
which essentially are markdown files.
Props.
And you can have different access policy for the wiki you have for the main document. So you can make the wiki wide open, but it's still version controlled, so you have full.
That sounds like the
Excellent.
right
So,
thing for this
wiki of the
to
BIS.
start.
Ira McDonald from the Jabber Room. I'm opposed to the first come, first served range. I suggest that specification should be required, be the minimum required process.
The reason would be very helpful.
Yeah.
No.
Yeah, Dave there. I was going to say, you need more reasons. The usual problem that comes up with very large spaces that have specification required is people squat on them if you don't have a first come, first serve. And so you got to have something that mitigates that.
Alexei Melnikov. Yeah, I think if we can review existing first come first serve registrations and see what their quality is, how many of them, that might inform our decision. But we don't have to do it now.
Sean Leonard. Regarding the tag space and first come first serve, I've noticed that we may have a reverse problem in Cbor, which is that because the barrier to acquire tags in the higher ranges is so low, we may find that there are deficiencies where we want to promote a specification or a tag to something that's much more generally or commonly used, in which case we have or may find that the first come first serve registration is insufficient, meaning that the specification quality is too low, right? It didn't have the right review. So the question is, do we now have to, should we assign 2 tags to it? And then what do we do with all the legacy data, right? That's using the higher, longer tag.
We could also split up the FCFS range.
Dave Taylor. Yes. Anytime that you have a specification or a lack of specification that's too general, then you usually have to change the number to get interoperability. Just like if you were going from, say, a vendor-specific proprietary protocol or mechanism to a standard one, you typically want to change it to make sure that you didn't have that compatibility issues. So yeah, that's the process that we use in many other code point or many other registries. So I don't see a problem with that, to say, yep, if you want to standardize it, you get a new number, and there might be a breaking change in between there, or at least you can't be guaranteed that there isn't one.
So I would like to make this discussion slightly more concrete by looking at the IANA registry as it is right now. So one trend is that people are using this FCFS range by thinking up a 4-letter ASCII word, computing the tag that resides from that, and then reserving that tag.
Oh, sorry.
So this is the on-part part here. This is the part where you want to the ISG to get the number. So this is all from the RFC, and COSI is the only other RFC that has dipped into that. Then the next round from 24 to 255, that would be the specification required one. And here we see, for instance, the tags that the Perl people have got. Somebody needs a rational number, so that they wrote up a spec for them. And actually the designated expert process can be used to make sure that that spec is useful. So I did provide some pushback on some of the registrations and asked for the specification to be more precise or fix something in there. So that's that range. Can you scroll up a little bit more? So 38, for instance, is this language tag string. There we had a pretty extensive discussion because people outside the IETF are often not aware of what language tags really are. But I think if we ever move this up to a document that is not just somewhere on a GitHub repository, then we probably would write more text about that as well.
Dave Taylor, you made me realize a comment on things that the working group should discuss, whether or not there's any actual action items, I don't know. And talking about these, there's a question in the industry, I think, at large about which ones of these are representable in JSON, because you have some places that do JSON to Cbor conversion back and forth. In OCF, for example, they do have things in data models that are in fact language tag strings. Okay, but since the way that they specify it is they say, here's how it is done in JSON, which doesn't appear on the wire, but the language of the specification is in JSON using JSON schema, patterns and the keywords in JSON schema and so on. And so therefore, when you translate from JSON to Cbor, they only use the subset of Cbor that you get when translating from JSON. And so what that means is their language tag strings aren't using the language tag string thing. Okay? What they're using is whatever the resulting thing is when you have like two strings in JSON, you convert it to this. I forget exactly how it maps, but the point is, yes, it's either not known or it's not used purely because there's not a JSON way, even though they don't use JSON, which is kind of an interesting artifact. And so I don't know if there's something for the working group to do other than be aware of this, and maybe there's something we can do to improve that. So think about that.
So if I may quickly answer that, I think we could document some more that you are not required or expected to use a tag that has been defined. So this is just something that can be used by an implementer that really wants to handle something at the decoder layer instead of handling it at the application layer.
James Woodya, Google. So these 1 octet, the low numbered tag numbers are a precious resource. And my experience in 6low is that when you have numbers like this that are a very precious resource, even when you are talking about standards action as the only thing that can get at them, there's going to be quite a lot of demand for that. And in 6low, when that demand started to be really serious on the dispatch code space and we had to come up with extensions, the proposal that eventually won there was the one that you see now in the, I guess it's an RFC now, it's the paging dispatch thing where there is a switch that allows you to switch out the page that corresponds to these tags. And I'd like to know if we might anticipate the similar kind of thing happening here.
So I think we're in pretty good shape on that because the extension space goes into 8-byte integers.
I know.
Naturally.
I know, but if you have a kind of data that is going to make a lot of use of an obscure tag, there is going to be a significant pressure on the idea of I can save 2 or 3 bytes every time I use this tag that happens 1,000 times in a message. That's starting to be significant. And I'll bet you that there's going to be demand for something that causes a parsing switch for those small, short tag numbers. And I'd like to open the discussion about that now.
Michael Richardson, so what you're saying is that it would be undesirable for them to allocate, say, 256 2-byte tags in a sequence because that would require them to repeat the first byte all the time. And they would want to have a code switch to say, extended, whatever, Woodyard page, and then they get to define their own. That's what you're concerned about, is that's going to be the pressure. And so then we would have a bunch of tags that would be interpretable only with the knowledge that the previous tag happened. That's what you're. I just want to make sure I understand your concern there.
Michael, that is actually already the case.
Yeah. No.
So there is one tag here, 256, that essentially enables the use of one other tag. I forget which one. Was it 28 or 29? So you need this outer tag, so the inner tag actually makes sense.
So we're already there.
It would be conceivable to have a logic that a tag can actually redefine the tag space for the data items that are inside the tag.
And in any but in any case, the tags would be clearly recognizable as tags, and parsers that are not really interpreting the tags, are just doing something, can still skip them when they don't understand them. So we don't have any loss of computation or whatever, generality of the structure for that. Pretty printers will get it wrong if they don't know about this new extension. Things that expect, a 25 to be a reference to the nth scene string when it's now, a compressed DNS value, we'll just see garbage in the value, but that's okay. They should, deal with garbage in the value at some point anyway. So I guess I share your concern, but I don't feel that anxious about it. I think we're okay. If we do get to that point, I think we're okay. And I don't think it's as bad as in 6low either.
So if you want to take that to the list, we can talk more about it there.
Sean Leonard. So just to follow up, something that should be apparent if you think about it is that the tags that are used in Cbor, the way it's designed, even though it may not be stated explicitly, are supposed to be globally registered. right? As opposed to contextual. Each tag can be defined so that it has contextual meaning. So you can have multiple tags that mean different things when they're stacked together or in one structure or another. But right now, the way that the registry is set up is once you declare to the world this number means this thing, then a debugger or readout or whatever should be able to take that tag and say, okay, it's always going to be this in every protocol or every context, which is fine. But I just want to point that out because that's the way that this registry currently works. And if you want to make something contextual, you can, but that has to be part
I
of the
could
registry.
also imagine a tag that sort of switched contexts.
Yeah, and actually in my draft, which I'll talk about later on during the session, has that sort of feature with OID tags, which is something I want to point out for people to think about whether that's good or not.
So just as further point on this, anybody can go ahead and register, say, 16 tags and just say these tags are there for other tags to use for their contextual stuff. That would just work. Okay, I think we have seen what we needed to see. So that was my last slide.
CDDL.
Okay. So let's go to the next item. So one interesting problem with doing RFCs in ASCII is that you don't have different point sizes, but we can fix this on the slide. So this is the author list of the CDDL draft. So I'm really talking about work that other people in Bremen have done and that I only have occasionally contributed to. So you cannot really talk about CDDL without talking about formal description techniques in general. Because in the IETF, we are very, very reluctant to make things dependent on formal description techniques. Why are we reluctant? Because at least the older ones among us really saw how formal description techniques killed OSI. It was not the only thing that killed OSI, but it was a rather significant force that made sure that OSI wouldn't work. Because they ran fully into error 33. They developed the formal description technique at the same time they were trying to use it, and that's not going to work. Okay, so the take-up of formal description techniques in IETF is pretty reluctant. There are a few notable exceptions. So those of you who are into history of the IETF may want to look at RFC 4997. However, there's also an island of formal description technique, the SMI v2 world, and later the SMP world, and later the Yang world. Those people really have embraced formal description and seems to work. Anyway, there's still one formal description technique that is rather widely used, which is ABNF. That's written up in RFC 523 form standard, and that actually even has been extended recently because it wasn't really helpful for newer protocols that tend to be case sensitive. So there's a little update on that. So let's talk about ABNF quickly, because that's the basis for what CDDL is. ABNF is based on the Bacchus normal form or Bacchus Nauer form, and that is essentially grammars for strings. And this has a really old history. So we're getting close to having 50 years of BNF usage in the IETF and its precursor. So RFC 40 is the first RFC with BNF in it. This was used for a while, and then somebody sat down and actually defined a BNF version that was going to be the standard version for doing specifications. There was no IETF in that sense at the time, but that's essentially the augmented BNF that we are still using today. So that happened 40 years ago in RFC 733, and Paul and other people old enough know this is the first mail standard that resembles what we're using for mail today. The mail people have been using that a lot, but also other documents have started using this. So at this point in time, 752 RFCs and internet drafts are referencing 5234. And that's not even counting the ones that are using an older version, because they are older than 5234. So there's pretty significant pickup. Compare this with Yang, which is of course much younger, which has 160 documents, both RFCs and internet. There's pretty good tool support, at least if you know where to look. So that there is Bilfenner's BAP, there's ABNF Gen, there is support for translating ABNF into ANTLER grammars and so on. So I think this is a bit of a model we can use, and we actually did use while doing this work. So anything that is done in the IETF that is text-based and isn't just XML or JSON is today using ABNF. Would be really weird not to do that. ABNF is essentially productions, like any BNF. So you have names for little sub-languages, and you have a composition mechanism so you can build complicated languages out of simpler sub-languages. And the main two composition techniques are concatenation. So you concatenate strings from the various sub-languages, like here, you concatenate a local part with an else sign in the domain. Or choice, which is a slash in ABNF, because at the time not all computers had a vertical bar, so they used a slash. And that is a choice between various strings. And the third element here is literals. Then there is a little bit of syntactic sugar, like 0 or 1, or 0 or many, and so on. Occurrence indicators that we can use to make things a little bit more readable. So that's essentially all there is to ABNF. And the idea is to use exactly the same basic mechanism in building data items, but data items are trees and not strings. So some changes needed here. And so first of all, you need literals for the primitive types, not just strings, but also other primitive types that the data model has. And you need constructors for the containers. So we have constructors for arrays and maps. We also have a slightly weird constructor for tags. Yeah, so it's all there. And these constructors have been inspired by RealXMG. So if you know XML, you know that there is something called XML schema. And the people who really know XML know that they don't want to use XML schema but RealXMG. Okay, so in CDDL, rule names are types. So you can say something like Boolean is false or true. A label might be a text string or an integer. And an integer, by the way, is an unsigned integer or negative integer. This rule is part of the prelude, which is loaded with any CDDL spec. So you have those names available. So types are just sets of potential values. That's all that there is to them. And yeah, even literals are types. So the number 1 is a type, has exactly one value in it, the number 1. And then you can compose these, for instance, by saying participants are either a 1 or a 2 or a 3. There's some more syntactic sugar here that I'm not going to talk about. And of course, all the data types that are important in Cbor can be written up. Okay, now the other thing we need to do is we need to build up those containers. We have arrays and maps in Cbor. So arrays contain sequences of entries, and maps contain sets of entries. That's one interesting observation. And the other interesting observation is that these entries are usually specified, usefully specified as types when you have arrays, or as pairs of keys and value types when you have maps. Remember that a type can be a single value. So for instance, for a key where you want to have a single value, that also would be a type in CDDL. So what we have done is actually we have unified this into the concept of a group, which has a sequence and also has these labels, these keys for each value, but the sequence is ignored within maps, and the labels are ignored within arrays. So this is an example of how the group mechanism works. So this is the technical content of RFC 7071 on one slide. A reputation object is a map that can have two map keys, application and reputants. Application is a text string, and reputants is an array of 0 or more reputants. And the reputant is a map with all this stuff in here. Some of it is optional, and here's a little bit of a catch-all. So this says there can be any number of mappings between a text, which is the label, and any is another data type. So this is extensible. This is defines itself as infinitely extensible. Okay, so we actually can give names to these groups. So if we want to use a group in multiple places, we can give it a name. And the fact that this is a group can be seen from the round parentheses that we are using here. The one thing that irks me most about CDDL is that we are using round parentheses, brackets, and braces to distinguish three really important concepts. So you need to look at the specs in a large font. And in a small font, you're not getting it because you're confusing parentheses and braces. Okay, so named groups allow the reuse of parts of a map or an array, and they essentially replace the feature of inheritance that other languages of this kind have. So if you want something like a base type, you put that into a group, and then you can inherit from this base by just using the name of the group in the map or array constructor. Okay, the little tutorial ends here already. This is another example. This is not the most recent spec. Brian will see that. But it's another example of what we're doing in the protocol specification. So we have this type message, and the type message is progressively constructed using /equal. That's something, again, that we saw from ADNF. So this means whatever was allowed as a message now gets another type choice, which is this array here. And the array has one element that is exactly the number 1, 2, 3. Uppercase and lowercase is the same thing in CDL. It's case sensitive, but there is no special meaning to uppercase. This is just a C language convention to write constants in uppercase. The session ID is a number that is representable in 3 bytes. We now have a better way to say that, but this is really stolen from 01. And then there are 0 more options, and options, again, are built out of various type choices, and this is the waiting time option, which is awaiting and awaiting time. Now this is pretty interesting here because there is a comment here. The red thing is a comment. We don't have a way in CDDL to talk about semantics. This is all structure. We are only doing structural interoperability. We are not doing semantic interoperability. That's certainly something you can discuss about, but this is what CDL is today. Okay, that's referenced by page, not quite as full as the one of Cbor, but there's one interesting thing I just noticed a couple of days ago. There's actually the first RFC out that already uses CDDL. Informative, of course, because CDDL isn't done. But I think that shows that we have to be a little bit careful in not breaking. There are other SDOs using CDDL. W3C has a few drafts out. Cannot talk about and cannot talk about also have documents that use CDDL. We are getting feedback from them, so we know that they're using it. But yeah, the usual closed house standardization
Hi, this is Hank from the title slide. Maybe it's interesting to indicate what is represented, which encoding with this CDL use.
Which encoding?
Yeah. What the CDL is actually producing in some of these cases.
Well, in some cases it's JSON, in other cases it's Cbor. And actually the first RFC 8007 or so that I just had on the previous page, that is actually describing JSON data in Cbor. Because the JSON data model is a subset of that of Cbor, it would be very strange if that wouldn't work. So there are things like features in wireless radios, aggregation of metadata, and so on. So I'm giving away a little bit. These organizations might be, yeah, if you look at the length of the underscores, you probably can find it. So this is going on, and we probably don't want to disturb their ongoing activities. So when we try to move this from a draft to RFC, I think the first rule is we don't want to break it. Well, I'm pretty sure the second observation is this draft requires some editorial improvements. As you can see from the draft name, the original author of the original document has changed jobs and is not working on IETF things anymore. And this document went through a number of pretty heavy changes. So we want to work on the editorial quality of that document. But while we are doing that, we still have the ability to actually add features to the language. And we probably don't want to turn this into a schema language or something like that. It should stay structural interoperability language, a data definition language. Yeah, anything that is in this overall tree grammar envelope probably is something that's worth looking at. And of course, the inverse is also important. There are a lot of things in there. Is there anything that we want to get rid of because nobody uses it? Or worse, people use it and generate interoperability problems with it because they don't understand what they are doing.
Yeah, this is Hank again. One of the consistent feedback we had, and a problem we still have no actually solution to, is a consistent example that goes throughout the document. Yeah. So we had a lot of nice examples by iterating problem with problem and problem. All these examples made a lot of sense. And then we have a very, very friendly user feedback. And he was like, these examples make me crazy. Please make them consistent. So if anyone has an idea or some use case in the back of his head that could be used as an example, we're also always welcoming for input. But at some point, we will have to make our own if there's none.
Okay, so let's quickly run through a number of things that have been suggested by people, just to prime your mind. So one thing that's a bit unwieldy right now is CDDL can't compute. It can arrange things in a tree nicely, but you cannot do something like, I have a base value, 400, and A is base plus 1 and B is base plus 2. Yeah, do you need that? I don't know, let's talk about it. More obvious maybe is the lack of string concatenation, because as soon as you have complicated regular expressions, in CDDL you have to write them on one line. And that is a bit unusual. So that's one thing that has come up. Some people want to avoid having to give names to groups. They want to be able to extract a group. Dave?
Do you want comments as you go along or comments at the end about your specific?
No, go on. Come on now.
So on that one, the second bullet, Dave Thaler. I'll mention both. I'll start with the string concatenation. As you mentioned, it's already done in ABNF supports that. And whereas the integers relative to offset is not done in ABNF. And so I think there is a valid argument that says it should be no less expressive than ABNF. And so that would be an argument to allow string concatenation, but it doesn't actually it doesn't actually answer your first question. But it does mean that there's plenty of text-based protocols that did not see a need for that. And so right now, I guess if you go by precedent in other spaces, right, it would argue for no on the first one and yes on the second one, but it's not a strong answer in either direction, right?
Matthew Miller, I would argue that as a general principle, we should try to go with things that present the least surprise. And programming-wise, this might make some sense, but from a documentation standpoint, computed literals can actually generally will often confuse people. So I think, like in this particular case, I think it's probably not a good idea. And I think in general, we should try to think about, somebody looking, going through their document, maybe have scanned CUDL briefly just so that they can read the document they actually have to care about to understand things. And I think it would be good for us to take that kind of stance when we're looking at where to take CUDL.
Hi, Sean Leonard. So I raised some of these issues, I think, earlier on the list that actually, I think that the principle of least surprise should mean reusing syntax from other commonly used languages where possible, rather than computing literals. In the case of string concatenation and interpolation for regexes, there actually is syntax already for regular expressions in a number of languages, most notably JavaScript and Perl, which treat regular expressions as starting with slashes rather than strings. So maybe that example may not be the best, because rather than treating a regular expression in CUDL as a string, it should be treated as an atomic sequence of symbols, basically, and have the exact same rules as it does in JavaScript or Perl. So with ABNF, you can have an ABNF rule on multiple lines, but there are atomic parts. For example, you can't split a rule name across multiple lines. So the problem here with string concatenation is if you treat the regex as an atomic piece, right, then it should be on one line, or should follow the rules for folding that Perl or other languages use.
Dave Waltermeyer. So we should also think, I think, about how to reduce the computational complexity of where the CDDL is going to be used. And so doing things like computed literals are a nice syntactic trick to help the author, deal with like incrementation, but it's going to be a cost that we'll have to pay every single time we load a CDDL, to use it to validate some content or something like that. And I think we should do things. We should have syntax that makes sense, but we need to weigh the trade-off versus what the performance cost is going to be. And this seems to me like something that might be the wrong kind of optimization. We might want to force the author to flatten it instead of supporting computing literals.
So Dave Taylor again. So Sean maybe realized an important distinction on the string concatenation point that I hadn't realized before he got up, which I think is actually a key distinction. In ABNF, when it's used for text protocols, you can use ABNF for two different purposes. Okay? You can use it for composing protocol constructs. Some of those protocol constructs might actually be literal strings, but the protocol itself is one great big long literal string. And you can use it for composing literal strings that might be in a particular protocol slot. Okay? In other words, you can compose regex patterns for specific strings in a larger context. And so those are two different things. And my comment about ABNF kind of convoluted that, and Sean was pointing out the difference, or at least made me realize the difference. And so the other point of comparison besides ABNF would be JSON schema, meaning json-schema.org, which has been through the IETF, kicked out of the IETF, decided to be done outside the context of the IETF, and various SDOs reference it because the IETF didn't take it. And I mentioned that one rule of thumb might be it should be no less expressive than ABNF. You could take the same tack that says, well, maybe we should look at being no less expressive than JSON schema because of the issues I mentioned before, as people that specify stuff in JSON but use Cbor on the wire. And so it's an interesting data point that, to my knowledge, in JSON schema, within a protocol slot, It supports string concatenation stuff because it uses regex patterns in the markup, but it does not support integers relative to an offset. And so my same conclusion that I came up for the first time still holds, but for a different reason.
Hannes, a coworker of mine did this JSON schema work, and we also entertained the discussion in the IETF, and ultimately it got rejected. And one of the reasons was, for remember correctly, was that specifically with JSON, the argument was, oh, we don't want to have the same sort of mess as with XML and RelaxNG, where you run into all these problems. Like, it sounds like a cool idea to describe protocol elements in that way, but it's typically a mess, and it's often out of sync with the text in the document and so on. And so now we are essentially doing a JSON schema plus Cbor schema, kind of, and are these previously sort of stated arguments gone away, or did we learn something since that time, or what is your thought on that?
But Matt can answer that better than I can.
Well, okay, so mapping over again. So at least as far as JSON schema and JSON content rules, and I forget the other 5 that tried to show up here. The general thing is, at least my general impression, having chaired that working group and this, is the rejection of those was more or less one could say an overreaction to XML schema. XML schema went well beyond just defining what XML ought to do, and it went into, here is, thou shalt validate according to this, and that went too far for most people, but it was the only thing really for a good long time until RelaxNG came along for people to deal with this. Now, when we're putting this together, I think it would be, I mean, so for Cuddle, I think Carson and some of the other authors have been conscious of this, but let's make sure we're sticking to that what we're trying to do here is describe how the data is done. We're not going to try to go so far as to say thou shalt or thou shalt not for your results. And because I think that's what's ended up causing the rejection of all the other ones for JSON. So let's try not to do that here.
Joe Hildebrand from the floor. Let me, I've been thinking about a way of saying what Matt just said. Obviously, he and I have probably talked about this at least once. That what we're not doing here specifically is we're not creating a validation language. We're creating a specification language, and that's a radically different thing than RelaxNG or XML schema.
That's interesting, because when you remember like the COSI work, my understanding was actually it was exactly doing that. It was meant to be sort of generating code out of this, and so in some sense that was also the ambition that the XML guys had. Unfortunately, most of the protocols that we design are not easily generated. Are not easy to generate because we have so many options and so many different variants, so it becomes a little bit of a moot point, but it's sort of, there's a slippery slope.
Yeah, so this is Joe again. In particular, a validation language would probably tend to not allow extension points and objects by default, whereas in a specification language, it would be natural to always allow and whatever else you want to put in the object that may or may not interoperate. That would be up to the spec designer to think about and to express in some way, right? So it's not trying to constrain. So people tend to use XML schema where they receive a piece of XML and they run it through the schema validator to make sure that it is valid XML, and that's almost always wrong, we've found, in writing XML protocol implementations. And so trying to stay away from that style of enforcement makes a good amount of sense, but we still need a way to write down the protocols that use this stuff. So something that is roughly like ABNF or serves a similar purpose in the ecosystem. People don't tend to use ABNF as I'm going to put it into an ABNF compiler and then check my email message against that compiled thing. They tend to write code that's specific to that use case.
Dave Taylor, got online before Joe came up, and so I'm not responding to that because I'm not sure I understood all of it. But I think that the JSON schema discussion is technically outside the scope of this, although even if I think that JSON schema should be in the IETF, because otherwise it's going to be done anyway, just it would be done outside the IETF. I don't think that's the job of this working group. The reason I brought it up is to say, if we want CDDL to be usable for the things that we want it to be usable for, we have to look at what people are using instead right now in the lack of CDDL, right? And so people use ABNF, people use JSON schema, and if it isn't as expressive as those, then people won't use CDDL, right? That was my main point, right? And there is a relation, right? I'm saying there are other parts of the problem I would like to address too, but what this working group could do, I'm saying it should be as input to say, in answering these, my usual rule of thumb in answering any of your questions, not just this slide, is to say, okay, do we have evidence that one of the languages that people are using today for this purpose of expressing Cbor or some similar purpose?
So I just wanted to clarify, while you're still there, I have a clarifying question, Dave. Would that include features that those languages have that we don't have evidence that anybody's ever used?
No.
Thank you.
I'm arguing because I'm familiar with, say, the Microsoft document series, which heavily uses ABNF. I'm familiar with the OCF document series, which does not really use ABNF, although maybe they should, but it does heavily use JSON schema and so on. And so I'm familiar with a couple of other non-RFC ones besides the RFCs that Carsten mentioned and ones going on in the IETF. And so among them, I'm saying if Cbor is the common language across the wire, which it is, right, then people are using different languages to express how to, some, what was the different, the formal description languages or whatever the acronym is. People use different ones right now that's not CDDL. And if we want this one to be successful, we should make sure we meet everything that they're using today, but not necessarily the things that they're not using to Joe's point.
So Matthew Miller again. So, and this kind of goes back to, I think, everything that I think everybody has been saying so far on this overall concept lately is, but so especially for JSON today in the IETF, what ends up happening for describing it is people end up trying to write a bunch of text to describe it, because when they go to ABNF, they can't get expressive enough. And we haven't defined anything that you can use normatively, or we haven't accepted anything that you can use normatively to say this is how you can describe your JSON. I'm sure Hannes is going to correct me. But that's been a real problem for all these attempts, these documents in the all these internet drafts that are heavily using JSON, and it would be really great if we don't run into that same problem here. However, like Joe had said, if it goes to the point of being a validation system, that's where everybody's run into a huge number of problems and ends up then feeling they need to reject it and reject the thing it's being used for also. So that's where I'm coming from on this one. I think it'd be great for us to have something that, for documents that are using Cbor or JSON, can have a descriptor language so that they can be concise on how they're defining things. Because text is too verbose, but ABNF is too much in the weeds for these types of things.
So can I make a quick comment on this? So the 1771 people actually went ahead and wrote a formalized way of using the English language to express the constraints they wanted to express.
I understand that, and I think it makes things more confusing.
Absolutely. So when I read 1771 and tried to understand it, the first thing I did was translate this English into this, so I, as a computer science-minded person, can understand what's in the draft.
So, right. So I'm just thinking, I think we're all in venomous agreement that we want to do something better than text, better than descriptive text, but not so far as validation.
Yeah, and we're going to cut the lines on this topic.
Much of us are.
After Michael.
I might be out of sequence now. This is Hank again, out of sequence between agreement and disagreement. So, because I want to highlight a specific thing that Carsten shows with this slide. This is, I can read this. I can understand this, and I had tens of sessions where protocols, some protocols were defined where the question at the end of the session was, and when can we see this in specification format? And I was like, I'm just sending the update. So I wrote alteration to the protocol while session. And everybody was expecting like a delay of weeks to get a document or draft update that represents the results, the agreements and consensus of the session. And I was literally live updating CDDL. So this is the purpose, one purpose, and this is basically what Matthew just said. It's readable and it's fast. Also, it's one intent is to be communicated as a language between people, which we sometimes seem to forget to say all the time. It's a language between people. And if you can use it to validate something feasibly at the end without having that intent to be beyond going construction specification, that's a good thing, but that's not our focus. Yeah? I don't see a lot of thresholds to getting to validation. Problem there is you have bad error codes. It's like, no, it's not working somehow. But at least you get something out of it. It can be used that way, but it's not our focus. Our focus is increasing interaction between humans and machines and improving those. And validation is not our focus here. It is a valuable side effect that is achievable, but it is not steering the decision.
Hannes, I like what Henk said, and it may be useful to capture that in the document, sort of the intent of this, because from just going back to my experience with XML schema, the issue was or at least there was an unwritten assumption that you have to add an XML schema when you wrote something about XML, and it was meant to be sort of the communication with the implementer. So that there was this assumption that the implementers would generate the code out of this, which of course was plain wrong. The implementers really cared about examples in reality, and they didn't care about the formal description, which they didn't understood, and often the formal description actually guided the way how authors actually wrote the document, because on the way what constructs they were familiar with, which was even worse. So the specification went in a way that was just constrained by your ability to write this stuff. So if you can manage to add that to the document, I think this would be very powerful.
And sorry, just to interrupt, we did cut the mic lines after Michael. Sorry. If it's important. I know.
Michael Richardson. It's good I have the last word, I guess. So I don't know if we should have addition or math. I don't know if we should have string concatenation. I would be upset if the regexes were to change format, I guess. Because it seems to me that unless CDDL itself is defining bytes on the wire, that any specification that references this can simply refer to CDDL that is sophisticated enough to describe its needs, and that we effectively don't have to really obsolete any of them ever, right? So, so this isn't like a feature like if we don't put this in the protocol, it won't get implemented and shipped. And if we're not really using this for validation, which I'm not in favor of, then my question is, wow, why did we spend 35 minutes talking about this, and why isn't it simply in the RFC editor queue? because we want to reference this already, and
all right, so we'll get to that point. We'll get to that point in just a minute.
So that's my comment. I think we can do these as revs, and we can do them whenever we like, whenever someone needs.
Yep. All right. So let's. I have a couple of questions to ask the group. If you want, unless there's anything else you need to say.
Well, there are 6 more of these slides.
I think we probably have the gist. All right. Well, then let's go ahead and keep going then. But let's pick up the pace because we're running out of time.
Time box that.
Yep.
Yeah, I think I talked about this unpack operator briefly. Representation constraints is something that came up. Can I write in the CDDL spec that something is supposed to be definite length or indefinite length encoded? I'm not so sure that this is a good thing, because CDDL is at the data model level and not at the representation level, but sure, it would be possible to annotate CDDL with that. Yeah, that's maybe a research project, but the tool could have better error messages, and it sometimes would help if the specification writer would help the tool creating better error messages. Modules, that's the one thing that comes up sometimes. Do you need a way to stitch CDDL specs together in such a way with export and import specifications? I don't think so either, but people are asking for that. And the final thing I really want to do in the document is, just as we have a yin to yang, I would like to have a JSON interchange format for CDDL specs. So the tool writers don't have to write a parser for CDDL. They can take the JSON form and do their pretty printing, reasoning, transforming, whatever from this JSON form. But just as almost nobody writes yin, I don't expect people ever write this form, but it's just an interchange format between tools.
Before we bog down on any particular ones of these changes, I'm going to have some sort of process things that I want to talk about. So if you've got clarifying questions, this would be good. And other than that, it'll probably be overcome by events in just about a moment. So.
Okay. Sean Leonard, just wanted to talk a little bit about the constraints, because I think constraints are an important and powerful feature of CDDL. But one of the things in the draft, I believe, is that there are numeric constraints, so you can specify ranges of numbers. It would be much more powerful and I think easier to implement for implementers if the numeric constraints use a well-defined, very easy subset of a programming language like C or JavaScript. So you can say, you know, this value is greater than 0.
So let's not get into solutioneering just yet. Okay. But I think once we start talking about this doc, all those sorts of things are certainly possible.
Okay.
So clarifying questions in particular is what I'm interested in at this point.
Dave Woltermeyer. One of my understandings is from the perspective of being able to do pretty printing and conversion between Cbor and JSON. From reading the spec and talking to Hank and others, one of the things that I remember learning about was that there was a way to do both textual and integer value for labels. So effectively, if you have an integer value in Cbor, you can print out the textual value in JSON as an example. Doesn't that require that there be some guarantee of consistency between the Cbor representation and the JSON representation in order to make that feature work?
In the core group, we have an interesting discussion about how to number Yang elements. And maybe some of the interesting technology they are developing for that, the SID file stuff and so on, could go into a future version of CDL. I don't think it's right there yet.
I mean, we've been saying that we don't want it to do enforcement, but that's a feature that needs some kind of
Let's explore that as we go forward. Let's not lose that. So make sure you send something to the list, and we'll talk about that.
Yeah, and thank you, Dave. I heard that very often. Yeah, excellent. So clarification. Carson was talking about cuts for a second and helping a engineer to understand what's wrong. And I just want to highlight that the gap, the jump from there to validation is ultimately tiny.
Yeah. So let's.
So you see that the problem is somehow circular, and therefore we cannot exclude validation.
Well, let's continue to noodle on exactly where the edge of this is. But I think that there has been some pretty good consensus around at least doing the specification part. And to do any more of the validation bits, we'd have to talk about it a little bit more and get people a little bit more comfortable with it. Does anybody disagree with that characterization at this point? All right. So I just want to ask a couple of questions of the working group to see where we're at. If there's any other things that people want to bring up before we start asking questions about this doc, now would be a good time to do that. All right. So first off, does anybody object to us starting with this document, this CDDL document, as a working group document for us to explore this space? And the reason why I'm asking it in terms of objections is because I want to hear those objections and let us discuss them first. Okay, I don't see anybody objecting. So we'll take that to the list and do a formal consensus thing on it, but go ahead.
Do we have a sense of how many people have looked at the document?
Oh, that's a good question. Raise your hand if you've read this document. Read. Now, put your hand up if you have used it to specify a protocol at least once. Interesting. Okay. There were sort of a lot of the people in the room had read it, and a surprising number of those, 85% of them, had used it to write a spec. All right. The next order of business then is the name of this thing. Dr. Fielding brought up that CDDL is the name of a popular open source license, and so we should probably come up with some other name, which sounds completely reasonable to me. I don't want to paint that bike shed here, but let's on the list come up with some names before we turn this into a working group draft 00, so that we can have it be a clean break from where it currently is into draft Cbor whatever 00. Third question is one that we've sort of danced around a couple of times here. There are a lot of people that want a spec in this space to refer to quickly. They want to be able to publish specs that have references to it in its pretty much its current form. So we could choose to do a quick editorial pass on this document, rip out anything that is underspecified or not used or that sort of thing, or we haven't understood well enough yet, and publish a first version and then immediately start Abyss and put all those things back in. That's one approach we could take. The other approach we could take would be to try and nail down all the open questions and get a better first document. Does anybody have an opinion on those one way or the other?
Yeah, Rick Taylor. Where I've come to CDDL beforehand is I've got some drafts in progress, and I want to put a section in the appendix which cleanly supplies the information that is elsewhere in the text, but it's a human-to-human interaction. I, as the author, want to just put in some fairly unambiguous, less ambiguous than the English, but it's not required for verification. I want to clearly describe it because ABNF won't do it for me.
So I'm hearing you say you'd like something quickly that was less featureful?
I would like to strip out anything that smacks of automatic verification generation. And if we want to do that, then we can discuss it and do it elsewhere. And I'd like something that has sufficient ABNF style constructs to allow me to say, here's a container, here's an array of X. I might want to use some tags here. I don't need regexes. If you want to see what that text needs to be, go read the section 4.1, which says, and that text will be this, up to a point. Let's not get caught up in trying to evaluate whether these are right. So simple, stick away from auto verification for now.
Jim Shutt. I'm going to basically more or less be in the same camp. I mean, the annotations are nice. I don't care what I think about any of them. I want something that is easy for people to read, easy to understand, and out the door. I do have a question for the authors. Are there any features which are currently in the document which, if we did a fast rev, they think are drastically underspecified?
Good.
A notation not everybody cares about that took on quite quickly and is on a lot of the references is a within template-ish thing. Please look at that, rip it apart, make it stable. That's good. Regex can be just a huge line that doesn't ever fold. And we take care of how to make the RFC of that later through the listings. But yeah, the within stuff, I think, got on so quickly with so many people that we should at least look at that, at the very least.
Good.
Brian Carpenter, I just submitted version 11 of the Grass spec about a minute ago. It's the one we hope might even go to the IESG soon. By the time that gets to Auth 48, I want a normative reference to CDDL. So please take the short route if you can. And there's plenty of time to revise it afterwards.
James Woodyant, Google. I have written a spec using this language, but it's not one that's a public spec. It's possibly never going to be published. So from my personal perspective, I don't particularly need this to be rushed to standard, though I understand there are others who do. I did find a few places in the language where it seemed like my spec was going to be a little weird because of the fact that the language didn't quite do what I wanted. Most of those had to do with the generic feature, the generic type syntax, which seems to me like it's maybe a little underspecified in the doc. And if that could get in the list of things that stay when it goes to a quick publication, that would be really good for me. If the authors want to look at the stuff that I've got in more detail, I'd be happy to talk with them offline.
I would encourage you to send mail to the mailing list and point out these things.
I think I found the same thing when I was using it, so I think that will probably get several people who agree with you there.
So the generic stuff is in an appendix right now that has the title nursery. So it does need some more Himalayan care.
That makes sense. Does anybody have any other concerns about trying to take a slightly abbreviated path on this document for its 0th version, assuming that we're going to then immediately start Abyss once we get it published? All right, we'll again check that on the list to make sure that everybody's cool with it. Go ahead.
I think to fully answer that, Dave Waltemeyer, to fully answer that question, I think it would be helpful to know what would be cut. So if we could have a concrete document that we could look at that would be more of that kind of finished product, that would actually be really helpful in answering that question.
So please update on the GitHub.
Yeah, well, one problem is that, of course, people are using this in various places, and they are using features that we may not know they're using.
Yeah, so the one thing is to notify basically every author that's using that. That's machine doable. It might be bland and brute force, but that's one way to solve it. Also, we can create, of course, a branch or something on GitHub that addresses this.
But when we change the name to be a working group document, that would be an opportune time to be aggressive about removing features. I'm seeing a couple of nodding heads anyway. It's going to be painful no matter what we do, so.
Hannes, when the work on the COSI specification was done and it used it, CDDL, I said there's this dependency, and I was told that's not a problem. And now people are suddenly in a super rush when it comes to doing some work in a working group where people are supposed to make some decisions, and it sounds almost like rubber stamping to me, like why then ask people on making any decisions if you just say, oh, we can't disrupt the other people who are already using it. I don't know. I'm just saying maybe there is no need to change anything, but it's like if someone would come to the IETF and has an implementation and says, I have this work already, so you can't change anything, just accept it. People would be upset. Essentially, that's the same here.
Yeah, I think the working group will have change control. Let me rephrase that. The working group will have change control once we've accepted it as a working group draft. So part of what the working group will have to work through is what the consequences for backward compatibility are as we make changes and whether we're willing to take those or not. And that's a conversation that we have pretty frequently here at the IETF.
Rick Taylor again. Isn't part of that possibly having an audit of what CDDL features are currently being used by drafts that are in the pipeline to see if we can find that there's a common subset that gets used heavily, and then maybe there's one or two drafts which use the really funky stuff, and that will give us some insight quite quickly?
If that could be done quickly, sure, but I'm worried about both private drafts that aren't, so like I'm not convinced necessarily. So let's take a look at what will get removed and see what that looks like before we jump to conclusions about what the consequences of that are. And if the answer is, oh, they're all pretty much ready to go, and we just aren't going to add some of the features that we wanted to add later, then it's easy.
I would like to not spend more time on discussing whether to remove something that would be needed for fixing it.
That makes sense. All right.
Matthew, my only suggestion was roughly along those lines of maybe, if anything, you could start with the things that are in the RFC editor queue referencing this, take a very quick, like, ask the author to come back to you in a day, what are you using from it, and just get a general, you know, try to get a quick list of, because that's more or less the musts.
All right, let's call that topic closed. All right, so let's run through the other specs that we've got on the list here. We only have a half an hour left, so if you could do the 2-minute high-level overview hand wave. So let's start with the array tags.
One slide on this because I don't need more than one slide. This is based on work that has been done by Kronos and that later became part of JavaScript. They have a number of ways to describe homogeneous arrays at the API level, but that's also used in protocols that interchange these after that. So essentially, this is a table of things that can be in a homogeneous array. And the radical thing here maybe is that this is supposed to support both LSB and MSB first, which is different from what Cbor normally does, which is doing everything MSB first. But this is motivated by requests that came from people who have these homogeneous arrays, and they are not small. I mean, they're not big, but they are not small either. And they would like avoiding to recode them. So this consumes 24 tags in 1 byte space. And there's also 2 more tags for other homogeneous arrays to identify them as homogeneous, and a tag to build a multi-dimensional array out of linear array.
So I'm up here. This is Joe Hildebrand from the floor. I'm up here to make the same face that Matt just made, which I could tell from standing behind him even. Reserving this many tags, particularly in the 1 byte space, seems massively aggressive, particularly because one of the reasons why you use these sorts of things is to encode large arrays of numbers, and so saving a byte here or there makes no sense at all to me. So I think this is a good thing to encode and to have a mechanism to be able to send it back and forth interoperably. The particular design that you've got here, we could argue back and forth over. We could talk about different ways to encode it. So I like the basic idea. The particular design, not my favorite.
Rick Taylor, follow-on question. Your smallest integer, these are integers. I have a problem which I've actually spoken to you offline about, representing flags. So most of the flags I represent, I say, oh, well, it's an unsigned integer, and then there's rules about which bit is which. Boolean arrays, packed represent a homogeneous array of bits. Does this fit within this model? Or does anyone else have a better answer to this problem?
I haven't found anyone who actually would benefit from a tag for bit fields, because you usually don't process them this way. You keep them as byte strings.
Keep them as byte strings.
And so usually, pardon? Well, lots of people use flags, yes.
Yeah.
But taking
taking
this apart at the decoder level, which is kind of what having this as a tag implies, that's not usually the thing we do.
This is Joe from the floor.
Support for that.
Joe Hildebrand from the floor again. This is something that you might add in a later version of CDDL. You might have a mechanism for specifying that, which would not need an encoder decoder thing.
It's already in there.
Even better.
So we can switch projectors now, or can I just do the other 3 slides that I have?
Yep.
So this is unchartered work. We are not chartered to work on these, but this doesn't mean that we may not want to be aware. There is draft on time tags. And as you know, nobody knew that time could be so complicated. Okay, Americans usually understand this joke. Time, of course, is immensely complicated. And so the tags that are in the base Cbor document solve 85%. And the problem is that people are now running into those 15%. And so the resolution is limited. We only have POSIX time as a time scale. We cannot include intent information and other metadata. So what we decided to do, and haven't really been completing yet, is we wanted to define a kitchen sink and then throw away things from that later. But we first wanted to see what could people want to have in a time tag, and then reduce it to reasonable size. So there has been a little bit of critique on the mailing list. This is hideously complicated. Well, you usually use one or two of those options, but it's useful to have that. So this all got started when the Haskell people came in and said, we need picosecond time. How do we do this in Cbor? Okay, so this is one thing. One other thing I want people to be aware of, this is work in the LPWAN working group. So the LPWAN working group is interested in compressing things, and the compression scheme they have come up with is called SCHC, Static Context Header Compression. And the idea is that there is a place somewhere that knows what you usually do on this connection, and based on that static context, you compress things. And it has turned out to be useful to have a Cbor data structure that has identified places where data that are actually being exchanged are being plugged in. So it's kind of a form that is filled in by data that are going over the air. It's a really simple thing. Read it, you can read it in 5 minutes. This is probably useful in a lot of other places, but it has been designed to support SCHC. So my summary of what we have out there, well, Sean will talk about the object ID graph, the array graph. Okay, we need to discuss it. And these two here are off charter, and we even may not want to do it here because it's LPWAN work. Or we may try to grab it from them. I don't know. That's to be decided. Okay.
Yep, so Sean?
All right. Hi, everybody. I'm Sean Leonard from Pango Inc. And Carson Borman and I both worked together on this draft, which is for object identifiers, but also how to use them. And as we continue working on the draft, the scope sort of expanded, and really there's an open discussion that should be had about, you know, whether the techniques and other things that are proposed in this should become part of Cbor practice. So next slide, please. So basically, when I was working on this, the original objectives were simply to add object identifiers to Cbor as an identifier format that can be used at, you know, inside the protocol and extensively, especially where it's modeling pre-existing data structures or protocols that want to be updated to use Cbor. But again, we also added guidance in here. I added some guidance on how to use them properly, or where we think it's appropriate to use object identifiers versus other kinds of identifiers like integers or whatever that have already seen quite extensive use in Cbor. And then while trying to adopt other protocols and update them for Cbor, such as ones that rely on MIME or other types of identifiers, the problem was raised of, okay, well, how do we then use these parts of Cbor effectively? All right, next one. So quickly, for those who don't know about object identifiers, they're used quite widely throughout the IETF and other places. They're a managed hierarchy based on primarily positive integers or strings. And the key thing that may be different about them compared to other identifiers that we've seen around here is that they're variable length, and which means that they can be very short. but they tend to be anywhere in the 5 to 10 octet range per identifier. And they're supposed to only have equality semantics, but in some protocols like MIB and SNMP and such, there is some structure that's implied with the way that OIDs are assigned. There are two widely adopted wire formats that I think folks in the room should be familiar with, the dotted decimal notation and the BER encoding. The BER encoding is self-delimiting, and it's very compact in that it has about the information entropy of 7 bits per octet. But there is a plain ASCII version that's used and seen quite widely throughout IETF protocols. And then there's some notations there as well. All right, next. So as I mentioned, OIDs have some advantages. They can be very short. They also are language neutral, which means that if we are committed to internationalization and don't just want to hard code, say, ASCII strings everywhere, then we can use numbers instead, but numbers are variable length. There are already hundreds of thousands that are already minted that have well-defined meanings. And it used to be very difficult, I guess maybe 20 years ago, to find out what an OID actually meant. But now there are resources online, such as the OID info or OID repository database, that make it really easy to look up. So with appropriate tool support, you can hover over or click on an OID and find out exactly what it means in a particular protocol. But there are also some disadvantages, in fairness. Next slide, please. First of all, it used to be hard to get an ARC, particularly a shorter one. Nowadays, it is possible with just a little bit of effort to get ones in the 3 or 4 octet range. It also used to take up a lot of space on the wire, and Cbor is really concerned with compacting, how much space on the wire is being used to get a really short one. But about 10 or 15 years ago, relative OIDs were invented so that the base can be implied in many cases. It has been historically associated with ASN1, which people don't like, but it's used in many places other than ASN1 and can be conceptually separated from that. And other people may say, well, it's not native to Cbor, but it's not for every job, right? For simple closed enumerations, such as when you're developing a protocol that has 5 or 6 options and you know that those are the options and they're not going to be any others, then you probably shouldn't use OIDs. But when you want a more open, extensible mechanism where arbitrary parties can mint their own OID for private purposes or in a different SDO, or do something experimentally, OIDs can be very effective. So next point. All right, so the draft's been kicking around for about 1.5 years or so. The main kind of action here is that we'd like to figure out what tags to use. I've proposed tags 6 and 7, which of course are in the standards range, so they're very low. The expectation that at least I have is that if you're going to use OIDs, you're going to use them and see them as identifiers throughout significant parts of the protocol, which justifies using up that short tag space. The document also provides diagnostic notation so that diagnostic viewers of Cbor can show it in a user-friendly way, and then also provides guidance on when to use OIDs versus other types, like UUIDs, for example. Then the document starts to go into kind of broader applications of, how was I, and then how should Cbor as a practice start tackling other constructs, right, with Cbor. So the first one was, one of the use cases that I wanted to enable was using identifiers, particularly open and extensible identifiers, as keys to maps, so that you can have an arbitrary map of attribute types to attribute values, and then to have sets of, say, capabilities or attributes that are asserted, where the presence of the identifier or the OID means that the client or the server supports a capability, and if not, then it's omitted. So OID arrays and maps are discussed, including the possibility of factoring out the tag 6 or tag 7, so it's at the head of an array or the front of an array or an object, and then it applies to all of the elements in the array, thus saving n bytes or 2n bytes or whatever. So for large sets, it may make a difference on the wire. And then the draft goes into a couple other areas, namely sets and multi-sets in Cbor. So one of the implementation or one of the protocol issues that I was tackling was how do I provide on the wire an arbitrary unordered set of attributes that are asserted from one side to the other side. Cbor does not have an unordered set type. In contrast, some other protocol or format languages like ASN1 do have sets, but do not have maps. So I propose a technique, or we propose a technique in the draft to simulate sets essentially as a map of key items where the values of those key items are all integer 1. And conveniently, that means that if you have a multi-set where you want to say that you have, say, a basket of fruits, 6 bananas, 4 apples, and whatever else, you can just increment the integer and therefore save a lot of space on the wire. I wanted to present this as a technique for protocol designers to consider because that sort of technique might be something that we would want to model in CUDL, or other description languages that are meant to describe Cbor. And then, as I said, OIDs can be used to tag perhaps complex or articulated sets of data, like attribute values or algorithm data or whatever it is, in a way that is orthogonal to the flat namespace of Cbor tags. So if you want to use some sort of tagging mechanism to tag Cbor items in Cbor that are not Cbor, for example, certificates, MIME entities, HTML content, logs, whatever, the document discusses how we might do that. And the canonical example here that it deals with is the binary MIME problem, which Carson referred to earlier in his slides, because MIME as a tagging mechanism or internet media type is very straightforward. There's a header, which is just content type, the media type, 2 curlifs, and then what's supposed to be binary data. So, that's something that we as a working group have to discuss. Is that the right way to do it? If you want to include arbitrary, perhaps large content, just put it in a binary string and tag it as MIME, or what? Should we have a different kind of tagging mechanism? Yeah. Great. I think that, next slide, please. All right, so to get to the issue of when do you use OIDs versus other things, I provided kind of a sample decision tree. This tree, or the advantages and disadvantages, are already covered in the draft. But of course, I'd like to see if people agree with that or just disagree with it, if there's consensus or whatever. Because OIDs are not meant to be used, well, currently they're not used for the most part in Cbor. It seems that in certain protocols like COSI, integers are used as keys. But there are other places where I think OIDs or other types of identifiers like UUIDs can be used more effectively, particularly for open registration. Okay, next. All right, so that's pretty much it. So here's stuff that we as a working group need to consider. Do we adopt it? Has the scope become too broad in this draft? And how can we formalize, particularly this idea of enumerations? Because lots of protocols use enumerations, and it would be good to have a way for us to do enumerations, I think, more consistently and have guidance for Cbor implementers.
Cosmo, and there's one nugget here that I'm interested in. There are good tags defined by specification required registrations now. As a working group, we might want to pick them up. And I don't quite understand how we decide whether to do that, and if we do that, how that would be done, because the registration, of course, is owned by somebody else.
So this is Joe with my chair hat on. Number one, I'd like to have the documents that are registering these things, to a question that you sort of alluded to. I'd like to have the documents that are registering these tags be relatively small and relatively focused, so that we can think about one thing at a time and its design separate from the other things. So having OIDs and sets in the same thing, for example, would be, yeah. And what? Yeah. Yeah, that's my, unless somebody has a a reason why that shouldn't be. This is me giving management direction, not soliciting consensus, unless I'm looking at the AD to make sure that he's not going to have an issue with that. All right, fair enough. Number two, to your question about how would we go and pull in some of the existing specifications and make sure that they're good enough, I think what we could do is start by just contacting the authors and seeing if they're willing to come and bring that work here and have the working group take it up. But I think what we ought to do is focus on getting Cbor BIS and CDDL out the door first, and then pick up some of these other things, unless there's any of them that have some other sort of pressing need, or somebody's waiting on the output or something like that. So if you have those kinds of concerns, raise them on the list. But other than that, I'd like to get those first two big things out of the way first.
I do have a process concern. So I might be publishing a document that has a UUID in it, and I would like to use tag 37. That is just a registered thing. Is that a downref?
Let's discuss that on the list and come to a conclusion together on it.
Alexei, can I have a ignorant, follow-up to the previous discussion?
Can you speak up a little bit?
Yes, can I have an ignorant follow-up to the previous discussion? Do the registrations that require specification, do they have change control field in the template?
I don't think so, but that would be a nice thing to clean up in BIS.
Yeah, that exactly. So if
I'm pointing my action item finger at Hank. That was, let's review the IANA templates and make sure that they've got a change control field.
Then if somebody registers, in the lower tag in a lower range, and we really want to recycle the specification, well, we should ask the author anyway to participate, but if they're not responsive, we can just take over and
All right. So we got split the draft and.
Well, I think split the draft, we're not quite ready to adopt anyway until that's done. And we're going to work on the first two big drafts first before we pick up any of these.
Right, because in terms of, my own need, I guess, I was trying to use OIDs and CDDL. So that was sort of the driving factor for that, to get that assigned, incorporate.
Fair enough. All right. What else is on the... Does anybody need tutorial after all of that? I kind of doubt it, but if yeah, does anybody need 8 minutes? How about this? Let's finish 8 minutes early. If anybody has Cbor questions or wonders how it works or anything like that, come up to the front, and we've got a variety of experts here who will answer your questions. Given that, make sure you've signed the blue sheets. Who has them? Oh, no. Are they, who's got the blue sheets? All right. If you haven't signed them, please do. And thanks everybody for coming. Oh yeah, that's fine. I think we've got it. To be clear, you're absolutely right, but
Yeah, it's
I think we're okay.
It's okay.
Okay.
because
And the answer is there were. Yeah. It's good. It's the right discussion to have.
Yeah, sure. No, I didn't think it was necessary to stop at almost any point, but
yeah.
I mean, James got a little upset that I had the mic lines on him, but
Yes.
yeah.